So good morning, everyone. Wow, it's amazing. It's amazing stage and a great opportunity. We will wait. Okay, I can start. Okay. I don't see the presentation at the screen. Sorry about that. Okay, now I see it. So good morning, everyone. My name is Nir Dvir. I'm part of Massivit 3D that actually present also at the JEC World. Manufacturing molds in a conventional way consume a lot of time and money. Massivit 3D vision is to automate mold production. And Massivit 10,000 that you can see here at the picture is part of our vision to automate mold production for composite material using additive manufacturing. But additive manufacturing has also challenges. A few of the biggest challenges are speed and size. Massivit 3D is very familiar with speed and size. Oh, thank you. With speed and size for a few years already. Since 2013, our customers around the world are printing big and fast objects from marine, automotive, rail, and you can see a few samples. Also, prototyping full-scale concept models such as this car that was printed in France, furnitures, and end parts or prototypes for automotive. But we are not here to talk about it. We are here to talk about composite tooling. We are going to talk about the bottleneck, which are mold manufacturing. Today, to produce a mold in a conventional way, you need 5 to 8 weeks. You might say less or more, but this is the average that we talk about. But what if we could make it faster? If we could automate this process and create molds in days instead of weeks? The cast-in-motion technology will enable 80% faster tooling possibility. 80% faster, up to 80% faster tooling possibility. So how do we do it? Today, in order to create a mold, you need to create a master and a long process till you come to the end and can print your part. It will take you, again, we talk about 5 to 8 weeks. With the cast-in-motion technology, we talk about 4 steps that will shorten this time. The first step, as you can see, is the printing. It's printing and casting epoxy into the print. Then it is the curing. After it's cured, we soak it in water. The shell will crumble off, and we remain with the part to be finished. Again, the idea is to generate mold in days instead of weeks. What you can see here, we are going to see a short video about the Massivit 10,000, but please come and visit us at Hall 5. We have an official launch of the Massivit today, of the Massivit 10,000 at 3 o'clock. Let's see the movie. I think we need volume of the movie, the video. But I think you can. I think we can understand it also without the sound because it has subtitles. So normally I use videos to explain what I want to explain, but today I think I'm going to support the video, as you haven't got to hear the sound. But I want to jump directly into your skits, into your mold that you want to produce. And what you can see here is a mold already with the tooling, a mold already with everything that you need in order to produce it. On the left side, you see a head. This is our printing head. This is a dispenser. And out of this dispenser, we are dispensing material that will cure immediately with the UV light. Once we have the shell printed, a casting head will come and cast epoxy between the shell that was just printed. What applications can we cover, or is the Massivit 10,000 covering with it? We talk about mold, master, plugs, jigs and fixtures, mandrels, sacrificial pattern I'm talking about, and prototyping. Let's start with molds. The mold that you see here was printed on the Massivit 10,000 with just a few hours. As a standard process, you can see here the carbon fiber screen that was laid up and the part itself. Just to give an idea, within 12 hours, within less than a day, I have my mold ready without the need to having any master before or the entire process. And the weight is only 11 kilograms. You can see that it's almost 900 millimeter, just less than a meter height. More example, racing car seat. On the left side, number one, you can see the car seat with a specific design that we have done, tools that will be easy to handle, to put on the carriage or for anything of your process. You have the freedom in design and can print your freedom, your structure as you wish. What you see on the left side, it is the casted material and the shell itself. Number two is after we remove the shell, and number three is the carbon end part. Again here, it's almost 1 meter height, less than 2 days, only 42 hours to print it with 50 kilograms. More examples like Redom that can be printed in less than half a day and 18 kilograms. But mold is only part of what can be produced with the Massivit 10,000. We talk about tool, jigs, and fixtures, or even combination of those. Just as an example, we prepared something, and you can see it also at the Massivit 3D stand. Those are inserts that are getting as part of the process into the mold in order to allow a better workflow for your process, for the finishing process, for CNC in case that you are using. Mandrel, sacrificial core, very important. What you can see on the right side is just the water breakable material print. No epoxy is involved. Again, we talk about mandrels that can be printed, that can be higher than 1.50 meters, and printing within hours. Why do I need it for? In order to have complex mold for shapes that are complex or have a form that you cannot release the mold from. You just print a sacrificial pattern, and within a day you can have your mold ready. Once you print the sacrificial pattern, you lay up your fabric with epoxy, you let it dry, you dip it in water, standard water, and the shell will crumble off, will fall off, and you will remain with your part. Master and plugs. We talked before and explained that we want to save actually the mandrel part, but it doesn't mean that you cannot print also your mandrel. You can print mold, mandrel, master, plugs, anything, and there are cases where our customer would love to print also masters. In terms of prototyping or toolless manufacturing, for sure you do need that as well. And with additive manufacturing, with Massive 10,000, you can also produce end parts. Here is an example for motorbike or for the rail, actually here in France. Even a vacuum forming form that is generated by Massivit. Another interesting possibility is to leave the core, and to use your fabric composite material on top of the core as presented here at the jet ski hull. Let's talk a little bit about the technology. As you can see, the Massivit, we talk about a print volume of approximately 1 meter 10 by 1 meter 40, and the height of 1 meter 50. Diagonal, we can reach up to approximately 1 meter 70. And we talk about the capability to print directly the mold, skipping any process in just 4 steps, and we discussed it already, saving up to 80% of the time. The technology based on dual heads, while we are going to see here in the presentation on the left side, what you can see is the dispenser. The dispenser has a UV ring, and the material that is coming out of the dispenser is a UV curable, and with the UV ring we cure it immediately, and we save on time and material as we can print hollow objects. On the right side you can see the casting head, and at the casting head we mix epoxy just at the spot. Means that the epoxy is ready next to the machine, and once needed epoxy will be mixed and casted between the shell that I was just printed with the first head. To be more specific, why do we use this technology? With additive manufacturing and with the Massivit 3D technology, you can print complex shape. And this is our dispenser. The dispenser is responsible for the complex shape, for high throughput, and the fact that I'm printing just what I need without wasting any material, and full control of the resolution through this printed and accuracy. On the right side, what you see is the casting head, and at the casting head, we talk about isotropic, and I will go deeper into it in the next slides. We talk about mechanical strength, thermal resistance, chemical resistance, and at the end, we talk about efficient digital tooling. If we talk already about material, we are using high-performance materials. The Demengel water base, water-breakable material, you have to think about a material that will be cured with a UV, acrylic material that will be printed with a UV lamp, will be cured with a UV lamp, but on the other side, by the end of the process, has to fall apart out of the epoxy. But the material that we are developing, allowing us the high accuracy, the complex geometry, and of course the light removable of it out of the epoxy. And the cast-in motion material, we talk about the resistance for temperature and low CTE and true isotropic. Now when we talk about isotropic, in additive manufacturing, most of the technologies are printing one layer on top of each other. There is no molecule bonds between the layers by printing one layer on top of each other. And by that, you are getting an anisotropic behavior in X, Y compared to Z. While the casting motion, we are casting in intervals, those intervals allowing a full cross-link of the molecule and bond, and with that, a full isotropic geometry that very, very important for your production. Many application and industries are utilizing composite material. We are here to support those entire industries and application, and with the fact that we are able to produce molds in days instead of weeks, we are supporting those industries and open the bottleneck for all of them to develop and develop faster. Just quick, very quick about Massivit 3D. We talk about disruptive technology to be able to print very, very fast. Founded in 2013 and founded actually by 3D and 2D pioneers, people that are coming from this industry. We claim to print up to 30 times faster compared to others in the industry, and we have more than 50 patents. Massivit 3D systems are installed in over than 40 countries. The Massivit 10,000 that you see here, at the moment installed only in beta sites, and here at the show where you can come and see us, actually the official launch at 3 o'clock. I see that we have maybe 3 minutes for Q&A in case we have, but I truly recommend you to come to our stand and get full attention from our team for all your questions. I'm sure that there are a lot of challenges that we can help you to solve. Okay, I'm lucky, no questions? Oh, there are.
Hello, I'd like to ask one question. You just said the material will be cured immediately after it is printed. Is it be cured after you finish the printing the whole layer, or just it is, it is extruded from the spacer?
If I understand right, Massivit 10,000 is using two dual head technologies. The first printing head is using acrylic thermostatic material, where we do print one layer on top of each other. This is the water breakable. Later on, we cast in intervals. It's not layer on top of a layer, and by the fact that we are casting in intervals, helping the cross-link of the epoxy. For us, what is important is the characteristic of your mold of the epoxy. Okay?
All right, thank you.
I think we have another question here.
Hi. In the conventional way, in the conventional way of molding, either by hand layup or the conventional machines, you do molding in parallel. I would say you do multiple of molds at a time. So how would you compare it with the printing in terms of, I mean, in case of a massive mass production, I would say?
Okay, this is, I would translate maybe your questions. How many parts can you take out of one mold?
That's true.
Okay, that's right?
Yeah, yeah.
Okay, so when The bottleneck is, as we see it, is the time for the first part. In order to produce today your first part, you need 5 to 8 weeks. The casting motion technology will allow you to produce within days. So you can have your skids today and produce it. Now the question is, how many parts can I take out of this mold? It has to do with geometry. It has to do if you do it in room temperature or in autoclave. So we believe that in autoclave you will be able to do 100 parts to 500 parts. Still, you're going to, we are not coming to eliminate the conventional way, but the conventional way will remain where it is to produce the high amount, and Massive E10000 will release the bottleneck of molds. Okay? Think about it, that by the time that you are creating a mold in a conventional way, you can create 4 molds digitally. Okay? Thank you very much. I think the presentation stuck. Oh, maybe because I'm here. There is another last slide that I want to show. Yes. Okay, so you are more than welcome to see us at M46 Hall 5. All the team is there for you. And of course, I will also come to the back, and I will be more than happy to work with you. Thank you very much.